Tim Freeman, Project Director of the Embalse Life Extension Project here at SNC Lavalin. Thanks for having me today.
Thanks for coming.
In Canada. So I have a lot to ask you about the Embalse Life Extension Project, but first I want to learn about where you're from.
So I'm actually from this area originally. Spent time in various places, a year in Australia, and other time previously in Bruce County on Refurb Project. I've lived in now Argentina for a few years, and generally I would say around the area, but worked in several countries around the world.
Cool. And so did you go to university here in Toronto?
University was at the University of Waterloo for mechanical engineering, which is a school about an hour and a half from here.
So you studied mechanical engineering at University of Waterloo. How did you get into the nuclear field?
I joined SNC Lavalin Nuclear approximately 12 years ago. And prior to that, I had worked in machine design and worked generally for smaller companies building automation cells for automotive and medical industries, so industrial applications. And so getting into nuclear, an opportunity came up. I was approached and I agreed to come in and meet, and the rest was history.
Yeah. And so what did you know about nuclear before going into the field?
So I'll be honest, I probably knew as much as your average, engineer in Ontario, which is that I was already familiar with the CANDU technology on a very high level. But I would say nuclear specific, not that much. And it wasn't an aspiration. It wasn't as though in university, and I went through a co-op program and worked in several different sectors. It's not something that I aspired to that said, all right, I need to, get into the nuclear business. I can't wait to do that.
Yeah.
But fate was that the industry came knocking to me, and I was happy to help.
Yeah. So you mentioned that most mechanical engineers know about the CANDU technology. Is that just something that's brought up in your classes, or?
Not necessarily, but in Ontario in particular, we have pretty good penetration of the nuclear business. So in schools like the University of Waterloo, where there's a co-op program, cooperative education program, you will often see postings. In fact, in my time here, I've hired many engineering students, and so that permeates through the engineering schools, and the word gets out, and people get to know what the business is all about.
Yeah, and before you started working in the industry, were you aware of how much power was coming from nuclear energy in Canada, or was it kind of back of mind?
I wouldn't say that I knew the extent of the participation of nuclear into Ontario's energy mix. Certainly not the way I do now, and for that reason, it took joining the industry to truly gain an appreciation for that.
Yeah, and so you joined SNC Lavalin. What do you do to facilitate that learning curve of mechanical to nuclear engineering?
It is a natural fit, and for a good chunk of the years that I've worked here, I've worked leading groups of tooling design teams for the delivery in particular of the Darlington RFR retube tooling set, which was a significant effort and felt very close to home, right in my wheelhouse with industrial automation. In many ways, the retube tool set, and I don't know how much detail you either know or would like me to get into, the retube tool set is an industrial automation job, right? It's the application of standard mechanical principles tied with automation and controls, PLC-controlled devices. And because you're effectively working on a disabled, shut-down nuclear reactor, it doesn't require the same level of safety controls that you would see in an operating nuclear plant. And that's why it's a lot closer to an industrial automation job.
And so, which is your background.
Which was the background.
Yeah.
And so there's a very clear need to keep the technology current and be able to leverage experience that is already available in the marketplace in various industries. So Ontario had a fairly robust automation and automotive industry for many years, which was on a bit of a downturn about 12 years ago. It's probably the timing it matches. And what happened was it was coinciding with the need in companies like SNC Lavalin to develop a very significant amount of industrial automation tools in order to perform these retubing projects. So we have benefited, and you could argue the industry has benefited from that knowledge base already existing. In my recent experience in Argentina, the Embalse CANDU 6 plant, which we've just completed the refurbishment of and has started up, is located approximately 2 hours south of the second biggest city in the country, which is Cordoba. And Cordoba happens to be a center for the automotive industry within Argentina. And that project benefited tremendously from very knowledgeable, experienced PLC programmers, machine designers, builders, who were very capable of operating, troubleshooting, and otherwise maintaining the specialized tools that we prepared, built here, and sent down there.
Yeah.
And so they were able to leverage that experience that is local in the country, and they were very proud within Argentina to be able to provide the vast majority of the jobs on the project from local Argentinians.
Yeah, I mean, that's really important, right? Because it's like integrating their pre-existing industries with your expertise here in nuclear and the tooling, then will allow them to actually go ahead and build more nuclear and have the confidence that they can successfully refurbish those plants in the next 25 years without just reliance on Canada, right? And, it's providing them jobs as well.
That's right. So I would say even just about every country has similar aspirations, which is to develop homegrown ability to execute new builds, refurbishments, and operate plants. They took it a step further in Argentina, where they worked very hard to not only staff the job with an overwhelming majority, I would say 95 or 98% from Argentinians of the, let's say, 4,000 people that were on site for the execution of the retube, but also reactor components. And they worked hard where they needed to get specialized materials that were not available in the country, or expertise that was very valuable from select experts like ourselves from Canada, or others from Italy for the Ansaldo, for the BOP. They would bring in those experts, but they would otherwise produce reactor components, so pressure tubes, glandor tubes, end fittings, closure plugs, and they did all of that locally, and we're proud to promote and develop the local nuclear industry.
Yeah, that's amazing that it was like 95 to 98% Argentinian. Really, I didn't know that. And
there's a secondary benefit. Obviously, that stimulates the economy in a large way. In a country like Argentina that has some instability in the economy, they had a recent devaluation of the peso approximately a year ago, which has been difficult for them. It provided stable, good jobs for a lot of people. And when you consider the permanent plant staff, which is approximately 800 people or so, that is a huge bolster to the whole community, the whole valley that is supported by that. And it really promotes a good basis, a good foundation for many years for that community to thrive and grow. Right?
Yeah.
So by all accounts, from discussions with some of the folks that were part of the original construction, which started in 74, and I think it went online in 83 or something like that, 1983. The valley went from a bit of a backwater into a thriving, technologically advanced, community that was high-paid tech jobs for 30 years of original life. And on the heels of the freshly completed retube that we've just done, they've got 30 more years.
Yeah.
And there's a potential that maybe there's a second retube, a third life for a final 30 years, so up to 90 years of continuous employment in a high-tech sector in that valley, which would otherwise be very different.
Yeah, not to mention clean power.
Not to mention clean, reliable power.
Yeah.
That plant produces, I believe, 86% of the electricity needs for the province.
Wow.
And Cordoba is the second biggest city in the country, and it's central to the entire country regionally. So all things considered, as an industrial center that has a thriving automotive industry, it's largely fueled by this plant.
Yeah.
If you want to think of it that way.
That's amazing. And so did you got to go and live there for a year or two while you were working on the refurbishment?
So I was there for basically 2 years. As these jobs typically go, it started as a shorter commitment and extended. My family, I brought my wife and kids down, and
Aww.
they got to go to school there and study in Spanish. And
That's so cool.
That was great.
How old are your kids?
They're 5 and 7.
So they got introduced to, a new place very early on then, and a new language.
They did, and they really enjoyed it. In fact, I was just back there a few weeks ago for a steam generator thermal performance test, which went very well, and a startup celebration that was attended by some of the politicians, including the president of Argentina, came a few days later. But my kids said, how come you're going and how come I can't go?
Aww. So I have to ask, do your kids have any impression of the nuclear industry already? I know they're super young, but...
I don't think they truly appreciate where the power comes from when they turn on the light switch.
Yeah.
So I would say, no, not at this point.
Not at this point, but hopefully sometime in the near future.
Yeah, I think they're still fascinated by unicorns, so
yeah.
We're not quite there yet.
Baby steps.
Yeah.
Yeah. And so how was working in Argentina on the refurbishment? Was it any different than, say, when you worked on Darlington?
So I've now worked on the Bruce A. Restart Refurbishment Project, and I've worked on the Darlington Refurbishment Project, and now in Embalse. And I've visited some of the other CANDU sites in the past. I can tell you that there are absolutely differences, but there are also very much commonalities across all elements. They have a strong nuclear safety culture. They have knowledgeable staff. Generally, in Argentina, there's a couple of aspects that are unique about Argentina. They have many of the kind of fairly typical social welfare systems, which would be typical of Canada, like the equivalent of Medicare, right? Mm-hmm. But they also provide free post-secondary education. And so you have a very educated group. And especially when you're talking about the refurbishment of a nuclear reactor, it attracts people that otherwise maybe, as I pointed out, were in, say, an automotive industry. I would say they had a high proportion of educated engineers and techs, and they were qualified, capable, and very interested in learning how to operate, manage, and maintain the tools that we provided to them. And they did, I would say, an excellent job of production management, production control, because when you're in the retube proper, and I'm not talking about the, defueling and the layup stage of the job, and I'm not talking about the commissioning and startup stage of the job, but the reactor disassembly, inspection, and reassembly forms the basis of the critical path on a retubing project. And the retubing project is the core of a CANDU refurbishment project. So effectively, it's a production job. Mm-hmm. You have, in the case of the CANDU 6 reactor, you've got 380 fuel channels in an array. And in the case of the Darlington and Bruce configuration, there's 480, but it's basically the same thing. Mm-hmm. And once you've established how to operate the tools on the very first channel, you're basically repeating that, indexing along, and one by one, removing all the components in a row.
Okay.
And once your complete vessel has your fuel channels completely removed, and your calandria tube's completely removed and you've got an empty vessel, then you go in with rad-tolerant camera systems and you do inspection.
What's a rad tolerant?
Radiation tolerance.
Oh,
so basically
okay.
a regular camera would snow out and,
Yeah.
and become useless. So there are special cameras available in the marketplace that are tolerant of the radiation up to a certain point, and depending on the field, there's different cameras you can select. And with these camera systems, we'll go in and inspect the inside of the vessel that you wouldn't otherwise get to see, because obviously when it's completely assembled, and certainly when it's in operation, it's basically almost impossible.
Yeah.
The access is very, very different. And so, with the cameras, you'll go in and perform an inspection of the vessel. And in the case of Embalse, it was discovered to be pristine, clean, and in great shape, which is great news. And then you start the long process of reassembling with new components. And at the end of the day, the goal is that you've got effectively a new reactor. The calandria vessel itself is original, but you've now replaced all of the calandria tubes to complete the vessel assembly, and now you've put the fuel channels in. Mm-hmm. The final step is the feeders. Feeders are basically carbon steel pipe going from 1.5 inch diameter up to 3.5 inch diameter, and each fuel channel is fed on either side by a pair of feeders that they collect at a common header up above. Mm-hmm. In the case of the Embalse Refurbishment Project, and unique for the CANDU 6 plants, they replaced the steam generators. So with a steam generator replacement project, which was challenging and first of a kind and reasonably well, I would say very well executed, what we saw in Argentina was a project overall that performed very well, basically, I would say almost on plan and on budget, and they were very satisfied with the results in Argentina.
It's quite impressive.
Very
for
proud
the
of the work
nuclear.
that was accomplished.
Yeah. So why replace the steam generators?
So in the case of Embalse, there were particular challenges with some of the internals that had effectively corrosion issues, and it was unique to that plant. And so for that reason, it basically became an obligation if they were to extend that, the life of that plant, they had to do those steam generators. Most CANDU 6s will not require that operation, or they're not believed to require that operation at this point. And maybe I can back up a step and say, so the Embalse project was the third CANDU 6 plant to go through this life extension project. Okay. So previous to that, there was one in Korea and one in Canada in New Brunswick. And so this was basically the third plant. Third campaign, third generation of sister plants to go through this life extension, which is similar but a little bit different from what would have happened on Bruce Unit 1 and 2 in the past, and has now basically just been completed in Darlington Unit 2. Mm-hmm.
So, and I feel like from the third one, there's still a lot of things that you can learn.
Absolutely.
Because they're all so different, they're all going to have different components replaced.
Yes, and we take the OPEX, the lessons learned from each retubing project, and we build on that for the benefit of the next one. So it is absolutely true that the Embalse project benefited tremendously from having learned a whole bunch of lessons in New Brunswick and in Korea before that. And so, yes, there's challenges, and you sometimes have some stumbles, but you progress, you find a path forward, and you build on that for the next time around for the betterment of each subsequent refurbishment. Because effectively, nuclear refurbishment is critical to long-term operations, but essential for any nuclear refurbishment, just like a new build, is cost certainty, and you want to eliminate the scourge which has been schedule overruns. So schedule overruns has been a bit of a plague in the industry for many years, and I think that the Embalse project, most recently completed, is an excellent watermark along with the Wolsong project in Korea, and to some extent some of the other projects that have been executed, to say, look, we can do this, we can do it on a predictable schedule and budget, and we can basically assure you with another 30 years of long-term operation.
Yeah.
Right?
What were sort of the driving factors in actually being able to hit that schedule and budget?
I would say when you're in the project, there are some dark days, right? There are some times when you're looking for the light at the end of the tunnel. But at the end of the day, it's about perseverance, and it's about a lot of very capable people putting a plan into motion, working the plan. And I know this is maybe not in the weeds, but at a high level, that's what it boils down to.
Yeah.
Right? You meet your challenges head on, and you overcome in the face of adversity. When you've got trouble, you huddle together, you get in the war room, and you figure out, what do I need to do to get out of this challenge that we've got in front of us today?
Yeah.
We have a setback, something's not going according to plan, we've got a tool failure, or we've got a component that is not behaving the way it's intended or expected to, and you sit down, you huddle, and you make a plan, and you come out of that. So,
Yeah.
I mean, this is reality. You will occasionally have a challenge with, remember I described it as a production line. You're basically doing a whole bunch of repeat operations. Well, like any production line, you will have a failure rate. And let's say you have an error in one of the welds, or a roll joint, or something like that. Some of them you're prepared for, and you've got your failure mode and effects analysis in place, and it's just a matter of following through your decision tree. And other ones hit you out of left field, and you just have to huddle and come up with a plan and work through it.
Yeah. Was there any sort of setbacks that you guys saw in the plant in Korea and in New Brunswick, and then here in Embalse, that maybe you still don't know how to address completely?
No. At this point, we have not encountered a technical challenge that has not been overcome.
That's great.
And that isn't to say there won't be a new technical challenge in the future, because anything can happen.
Yeah.
But having done it 3 times on the CANDU 6 and another 3 times in the Bruce and Darlington configuration, so now having 6 retubes effectively behind us, there's fairly high predictability on what to expect from effectively this production line job. We certainly, I would say, through the last number of units, we've now identified that, for example, it's possible that you underestimate on a schedule or cost, and they relate, on a schedule basis, how the complexity of things like the feeder installation. So as I described, it's an awful lot of carbon steel pipe with an awful lot of welds. And on the surface, it seems like something that is straightforward, and it's just a standard piping installation job. And yet, it can be a real stumble if your weld program is not well developed, if you have any material issues, if you have any tooling issues, or you don't have your welder qualifications in place, if you don't get the fit up just right. So sometimes it's the basics. It's getting the basics right. And our experience, for example, on the Embalse project was just getting basic process control in line, and driving with intensity, driving down that weld failure rate, right? So things like that, it will surprise you. And what we'll take into the next job is to say, all right, so maybe what we need to do differently this time is focus on this area or that area, because that's where we had a pain point in the past. And we know we can do it better, and we know we need to prepare either a small modification to the tooling or to the plan or the procedure, or open up the specification. We have to find some way to make sure that we don't feel that pain point again.
Right. And are there any pain points that you think that you can predict at this point now, say if Embalse is to run for another 30 years and then need a refurbishment? Are there certain components that you think that you guys haven't been replacing that might need a replacement after, say, 60 years of operation?
So it's possible, and definitely condition assessment is critical. In fact, prior to this project, as with any of the CANDU refurbishments, or you could argue any refurbishment in the nuclear industry, you have a lot of commonality, whether it's a PWR or a CANDU reactor. You're going to be looking at the aging of materials, whether it's cables or metals or concrete. It kind of breaks down into those broad categories. And we do a lot of ongoing work, whether it's the analysis work in our engineering office, or whether it's our field services work, which is a cornerstone of our business here as well. We will collect field data through advanced NDE techniques. We can deploy inspection robots, if you will, either into fuel channels or other components, and we can detect flaws, wall thickness, we can detect material properties, we can do sampling, we can take an actual replica sample of a flaw and be able to determine its size and orientation, depth, that sort of thing. Or we can actually physically do a scrape sample, and we can harvest a small amount of material and have that analyzed in a laboratory and evaluate for the effects that come from being inside an operating reactor for many years. And we can continue to do those sampling on periodic basis and plot the change in time on a given channel or trying to predict what type of, and this is possibly somewhat unique to the CANDU industry. I'm not 100% sure how the PWR community works, but we often operate in EFPH, so effective full power hours. And so nominally, a CANDU gets enough effective full power hours to operate for 30 years, but it really depends on the capacity factor.
Right.
And so if you have a higher capacity factor, which some of the CANDU units have been thankfully getting, you end up with potentially a shorter life, unless you can do material and condition assessments that can allow you to, through advanced techniques, NDE and scrape sampling, be able to determine that, in fact, you can extend the life in the regulatory framework by making a case, an engineering case, and going to the regulator and saying, we're going to propose that we'd like to get more effective full power hours out of the current reactor in its current configuration. So I'm not sure if that answers your question, but this is to say that even before each retubing job is done, there is already a condition assessment performed to understand which components are put in scope for the refurbishment. We also, at the Embalse job, did an uprate to get 6% more power output.
Yeah, I was going to ask you about that.
Which was important.
Yeah.
And that's somewhat separate, but a refurbishment job gives you the opportunity for an uprate. And there was a significant amount of updating of the balance of plant, largely contracted out to Ansaldo out of Italy, who was the original constructor in that case of the balance of plant, original designer. And so you look at all those components all the way through the system, plus we now live in a post-Fukushima world, and there are certain upgrades that it was the right time to do to satisfy commitments to a regulator. And I'm speaking in general terms, this is how nuclear refurbishment often goes. You have a basket of activities in your scope, and you decide, okay, what do we need to do now? What is going to set us up for 30 more years of life?
Yeah.
Right? And so all of those things will happen, both condition assessments for small increases that might extend the date when you actually have to go breaker open and start the refurbishment, as well as all of your planned, and often it's large plant equipment, which in the case of Embalse, there were several diesel generators, a couple new buildings. Obviously, they needed somehow to treat and handle the retube waste, which is the metal waste, irradiated metal waste that comes out of the reactor. And there's storage facilities on site for that. And in general, they're planning out all of the people, processes, equipment, facilities, tooling, and making a holistic plan. And this is something that we effectively now have quite a bit of experience, and we work with the utilities to make the plan and continue in this way.
Yeah. And so you mentioned, living in a post-Fukushima era, and I'm just wondering how much events like Fukushima and the subsequent changes in regulations change how you guys have to do refurbishments? What, how did it change what refurbishments look like?
It's a good question. So I would say if you're talking about the retubing, which is the, overhaul of the engine, so to speak, if you're going to use the car analogy, the post-Fukushima doesn't really affect the nuts and bolts of what we're doing. Mm-hmm. There are typically more requirements from a safety and licensing perspective that affect the various safety systems, looking for additional redundancy in certain areas, looking for the availability or uptime, looking at maybe areas that weren't considered to be a threat in the 1970s when many of these plants were built. I would say specifically, as if you want to talk about what goes in the box for a refurbishment project in terms of what you need for long-term operation, often that is somewhat delinked from the post-Fukushima upgrades, which many regulators who have all generally gotten together around the world will acknowledge as being necessary, because in most cases they will tell you that those post-Fukushima upgrades are required either way, regardless of when the plant was built, and they're often not going to wait an extra 15 years to get them in place when it might be convenient for you to do a refurbishment job.
Yeah.
And for that reason I'm saying, if it lined up so that your refurbishment job was in the very near horizon, and you can convince your regulator that that's an appropriate window to wait to implement this new safety upgrade, then it happens to work out. But otherwise, most of the post-Fukushima upgrades are being implemented at the first available outage, and they'll take advantage of an outage to do that. So
then would it make more sense to say, you had 15 more years of life expected, but the regulator says actually within the next 5 years you have to make these upgrades to the plant based on the new regulations from Fukushima? Would it not make sense to do like the whole overhaul of the plant design? There are a variety of factors that a utility will put into consideration when they make the selection as to when to bring a unit down for refurbishment. Yeah. And this would be one of them, definitely. So it's up to the utility. You guys just... Often we will provide recommendations and advice, technical input. Often it's going to feed into what's best for them and their plan, and they look ahead and they look at the industry and available of manpower, because a refurbishment project of this magnitude takes a lot of resources. And for example, the province of Ontario is very interested in making sure that both Bruce and Darlington refurbishment projects are going to be concurrent, and they need to plan and work together. So there's a lot of considerations that go into the mix. Yeah. And so now that you just finished the Embalse Refurbishment Project, what's next for you? So there's plenty of work here in our home office, which is great. And at the moment, I am the director, phasing into a role as the director of the project management office for the field services. So with field services, we do work all around the world and largely in Ontario. And we support all of the CANDU community in maintaining, operating, and through inspections and other work, their reactors for long life. That's been a cornerstone of our business for many years. Yeah. So what's your day-to-day like then? Lots of management? Yes, it's working. We try to partner very closely with our key clients and make sure that we are meeting their needs. We are responding to when they have outage requirements, because it's outage-driven work primarily. Mm-hmm. And you've got outage schedules that have to be managed at all of the utilities, largely in Ontario, but also in all around the world, anywhere there's a CANDU. And with that, we have the obligation to maintain a core team of very experienced techs and engineers, as well as equipment
that can be deployed in various places for very specialized, as I referred earlier, advanced NDE techniques. We've got some exciting stuff going on with respect to how we can, for example, move garter springs around. You've got a pressure tube.
Okay.
And that's the primary heat transport system. It contains your string of fuel bundles. And on the outside of the pressure tube, you've got an annulus spacer, which is nicknamed the garter spring. And that is effectively keeping the gap between the pressure tube and the calandria tube on the outside.
Okay.
And occasionally those annulus spacers will drift in position. And if they ever drift too far out of position to allow the pressure tube and the calandria tube to make contact, it's a very undesirable effect. So it's very important to make sure that you not only know where the garter springs are, but have the ability to move them if necessary.
Yeah.
And so there's some very interesting technology that we're working with that was developed in Chalk River several years ago, where there's basically a tool that goes in and it grabs the pressure tube from the inside, and through piezoelectric actuators, it induces a harmonic, and that harmonic from the inside of the tube is able to move the garter spring on the outside of the tube.
That's so cool.
Because otherwise there's no way of getting to it, right?
Yeah.
It's sandwiched inside a reactor. So stuff like that. I mean, there's lots of very interesting and very, very specific tasks which we get into.
Yeah.
Right? But big picture, I mean, we would like to participate in nuclear refurbishment at the CANDU stations all around the world. And with that in particular, the retubing. We have developed the tooling, the people, the expertise, and with every CANDU effectively coming to the end of its nominal 30-year life in a progressive schedule, depending on when the units came online, there are still many refurbishment opportunities yet to come. We're a strong believer, I guess, speaking personally, I'm a strong believer that CANDU refurbishment is very important for the energy mix in all the jurisdictions where CANDUs exist today as a method of reliable, safe baseload power. And I don't think that there is a viable replacement or alternative. So I think we would like to be part of these refurbishment activities. And I think that CANDU has a little bit of a unique framework in that my understanding is all of the jurisdictions where CANDUs operate will typically have license conditions based on effective full power hours. That is the approximate 30 years that I'm talking about. Generally, but not always, I understand in the PWR community, their life extensions are in smaller slices. So they will often approach a regulator with a safety case based on very specific activities, but it's often only in the 10-year range.
Oh wow!
And maybe 20, but it's a lot less. And that's why a CANDU refurbishment usually will give you that 30 plus 30, and we'd like to think that it's 30 plus 30 plus 30 for a total of 90. And I think nuclear power still struggles with reputationally around the world, and I also think that the renewable market is not ready to supply a stable grid, and so I think in the foreseeable future, until we have a complete different approach to storage and the efficiency of storage, I think that nuclear power has a very important role as clean energy in the baseload market. That is somewhat irreplaceable based on the technology available today. And so for that reason, I think it's important that we keep promoting nuclear refurbishment in a way that's reliable, safe, and against a backdrop where nuclear new build would be wonderful, but is up against a brick wall of cost and schedule predictability and general population acceptance. I think that nuclear refurbishment is by far and away the next best thing. It's predictable. It's building on what's already known and accepted by a community. And it's a matter of keeping the supply chain intact, which is very important. And luckily in Ontario, we have a fairly substantial and strong supply chain, a basis. All of the committed nuclear refurbishment operations, the retubes that are on plan, including the Darlington one that's nearly complete, the first unit, will allow for that supply chain to continue, for the workers to continue to learn their craft and become and stay experts and maintain these reactors. And it would be nice to see in other jurisdictions around the world, especially where they have multiple units. Argentina is a bit of a unique case because they only have a single CANDU 6 station, a single CANDU reactor. Mm-hmm. They do have 3 reactors, and there was a plan previously to build a 4th reactor, which would have been CANDU. When the peso had trouble a year ago, it was subject to cancellation, which was unfortunate. And so I'd like to see the next generation of CANDU 6 or CANDU reactors being built. But until that happens, we need to promote nuclear refurbishment as an equally important and viable future alternative.
Yeah, absolutely. And on the note about Argentina, I mean, hopefully after this new refurbishment, they'll have like a more, lucrative economy and hopefully be able to build that 4th reactor. But also, I know it's not exactly your expertise, but in my mind, when I hear refurbishment, like if I'm not from the nuclear community, I think of like maybe sending my iPod in to be refurbished, and then you get it back and it's not as good. And like, that it's not as good. So do you think that marketing it as refurbishment is going to make the public not trust it as much, or does that not even matter?
That's interesting. I never thought about it that way before. but I take your point. So we often brand these as life extension projects.
Right.
Right?
Yes.
And so we call the Embalse Life Extension Project. And in Argentina, they use the same, just translated, they say Proyecto Extensión de Vida, right? And there's a funny side anecdote to that. We had, when we first sent our first team down there, they had shirts made up that said Embalse LEP, for Life Extension Project. But we were not aware at the time that Embalse LEP is a bus line that operates in the valley. And so the locals thought that the shirts were great, except they weren't going to wear them because they didn't want to be called bus drivers. No, but your point is valid, and so we use the term nuclear refurbishment broadly, but life extension is a fairly well accepted term, and I would say that in the projects that I've worked on, even though you have oversight by the permanent plant staff, engineers, operators, largely the work is executed by project teams. And usually the plant staff, the operators and engineers from the utility are very interested in what they're going to get, and would absolutely want that brand new iPad as opposed to the one that's got some scratches but now has a new screen on it.
Yeah.
Right? At the end of the day, from a project level and that negotiation that happens in the turnover documentation, there is always going to be that very strict and demanding standard that is the utility holding the project team accountable, and that's been my experience. But it is not a brand new plant, right? Now, I would counter from a public perception standpoint to say that it's probably better that it's not a brand new plant, because a brand new plant comes with a little bit of risk and uncertainty that things aren't going to operate as designed. Whereas when you rebuild a plant, you know exactly what you're going to get. Yeah. Right? And it's more like, let's come back to the car example, right? So if you had a classic car and the engine was tired and it needed an overhaul, you needed a complete engine rebuild. Well, chances are, other than that engine, which is usually certified and going to do very well, the rest of the car, you know what you're getting, right? And everything's replaceable. As opposed to you get a new car off the line and there's combination of maybe they don't build them like they used to, as some people sometimes say about cars, and also sometimes you get a lemon, right? So
Right.
Sometimes it's better to have predictable results. And what we also see is that when you've got the plant staff, the engineers and the operators that have been maintaining a plant and operating a plant for many years, they know that plant inside out. Mm-hmm. They know, in the case of the CANDU, they know the fueling machines, they know everything like the back of their hand. And they are experts on exactly that equipment. So it's usually better to give them back mostly a rebuilt version of what they already have, mm-hmm. because they know exactly how to maintain it, they know how the systems behave, and it is, from a plant perspective, a desirable outcome.
Yeah, you sold me on refurbishment. And as we wrap up, just to throw you a hard one, so since everything is recorded these days, we're recording it in video and audio. This video is going to be around for quite a while, so it is possible that your kids might see this, might go back and watch this when they're older. So as the nuclear industry stands today, what do you have to say about it now to your kids that you hope that they hear in the future and can reflect on?
So I hope they see it. I mean, that would be good. I know that as opposed to what is typically the burning of fossil fuels for producing baseload power, which is the vast majority around the world today, which is contributing to a big mess with respect to pollution and climate change. Nuclear may not be perfect, but it is the best alternative that we have today. Generally, hydro is tapped out and comes with its own problems. And renewables are very important and will have a future. And once reliable, efficient storage is in place, it might be a different equation. Mm-hmm. But for what we know today, it's very important that we don't let all of these nuclear power plants be decommissioned, and because we will be affecting our children and affecting our future.
Yeah. Tim Freeman, thank you so much.
Thank you.